Hi, I'm Rosenberg, the CEO and Chief Scientist of Unanimous AI, and today I'm going to be talking about collective superintelligence, keeping humans in the AI loop. So why collective superintelligence? The fact is we're about to enter an age when AI enters the workforce in a really big way. And we really need to understand the implications of that. And to help, I created this fun cartoon with a man on the phone saying, don't worry, he's a great employee with lots of experience. And there's the AI just consuming massive amounts of data. And my point here is to convey that data is not insight, knowledge is not wisdom, and humans still have a very significant part in this workforce because we bring knowledge, wisdom, insight, intuition, values, and sensibilities. And the goal of collective superintelligence is to use AI not to replace people, but to connect large groups of people together with AI agents to enable a collective superintelligence that keeps humans in the loop. So the big question I'll be talking about today is how do we build collective superintelligence? And it turns out that Mother Nature has a name for amplifying the intelligence of large organizations. It's called swarm intelligence, and it's the reason why birds flock and fish school and bees swarm. They are smarter together than alone. And so today, in terms of an outline of what I'll be talking about, I'm going to start with swarm intelligence, nature's method for amplifying the intelligence of groups and making really smart decisions. And it's not about aggregating data. It's about forming real-time deliberative systems. Then I'm going to talk about artificial swarm intelligence, which is enabling swarm intelligence among large networked human groups. And the first generation of this technology was called Swarm AI. It's still being used. I was involved in developing it back in 2014. And then the second generation, the next generation, which just emerged less than 2 years ago, is called Conversational Swarm Intelligence. And this enables us to have really large groups engage in deliberative conversations with amplified intelligence. And by very large groups, I mean 50 people, 100 people, 500 people, potentially 5,000 people engaging in deliberative conversations in real time to amplify their intelligence. Then I'll talk about Thinkscape, which is a new software platform for conversational deliberation at scale, 50 people, 100 people, 500 people with amplified intelligence. Specifically talk about recent research studies that were conducted at Carnegie Mellon and elsewhere that show the value of conversational swarm intelligence. And then finally, I'll talk about collective superintelligence, where we end up with use cases from enterprise collaboration and consumer insights to civic engagement and big science. So why collective superintelligence? And the answer and the reason is because of a very controversial concept in the world of AI, namely people are smart. And I know that sounds like a joke, but the truth is, I go to a lot of AI conferences, and I never hear people starting with the principle that people are smart. Instead, they're starting with the principle of, hey, how can AI replace people and do better than people? And so I think it's important to take a step back and say people are smart. People have vast amounts of knowledge and wisdom and insight and experience and opinions and intuition and expertise. And the big question I've been asking for a decade is, well, how can we harness and amplify the intelligence of large groups so that we can make smarter decisions, solve harder problems, and generate more accurate group insights? And my driving philosophy is that people are not just data points for mathematical aggregation. And I say that because in the field of collective intelligence, so much of the field is based on collecting data from people through polls and surveys and interviews and then aggregating it. And that's not people. People are data processors that can think and deliberate together and converge on answers. And that's what brings us to swarm intelligence. So swarm intelligence is nature's method for amplifying the intelligence of large groups. And what nature does not do is nature does not take polls or votes or surveys. There's no survey monkey in nature. Nature doesn't analyze big historical data sets. There's no big data in nature. Nature forms systems, real-time systems with feedback loops that enable the groups to deliberate and converge on optimal solutions. And by deliberation, I mean, at least in a fish school like this, it's a dynamic tug of war among the participants where they push and pull on each other and they find the solutions of maximum collective conviction. And researchers have shown that that's almost always the best solution. And these large groups, therefore, make much smarter decisions together than alone. And so, a big question is can large human groups form a real time swarm intelligence? And that brings me to artificial swarm intelligence, or swarm AI, which my team at Unanimous developed in 2014. And what we did was we studied biological swarm intelligence and we developed the algorithms and interfaces to enable humans to form similar systems online. And so this is an artificial swarm intelligence. It's about 100 people. They're all working together to answer a question. Each of the little magnets that you see is controlled by a person in real time. They can be logged in from anywhere in the world. And as they move their magnet closer to this puck, they're applying a pull, and they're all moving and adjusting and negotiating in real time while AI algorithms are watching their behaviors. And so what happens is a question appears on all their screens at the same time. In this case, what's the probability that interest rates will rise over the next 4 months? And the group is negotiating. And so Swarm AI is a real-time system with the participants acting and reacting and interacting, revealing the strength of their convictions to the underlying algorithms. And what's really cool about it is that what the people see is really simple, right? They don't require any instruction. They just use your mouse or your touch screen on your phone to control the magnet and answer this question. But what the AI sees is this cloud of behavioral data that it uses to assess each user's confidence and conviction in real time. And it's a feedback loop, which is what makes it work. So a question appears, everybody moves their magnets, they behave, the AI looks at everybody's behaviors, assesses their confidence or conviction, the puck starts to move, and as soon as the puck starts to move, everybody changes their behavior. We're evoking more information. So the people in the AI influences the people influence the AI, and the system converges on solutions. And those solutions are almost always significantly smarter than traditional methods. And so let me give you an example. So one of the things that we did at Unanimous AI is people would say, you've got this technology, does it really work? Prove it to us. And we would ask journalists, well, give us a challenge. Happy to take on challenges. And so here's a fun one. A few years after we developed artificial swarm intelligence, we were challenged by CBS Interactive to predict the Kentucky Derby. And not just the winner, we were asked for the first four horses in order, and that's called the superfecta in horse racing betting, and it's like the biggest long shot in sports. And the normal way that an AI company would do this is they would train a system on a huge amount of data about horse racing, all kinds of information, and then try to extrapolate and make a prediction. And nobody's ever done that to make that work. What we did was different. We started with a human database. We took 20 people, horse racing enthusiasts, not professionals, but people who really know horse racing, and we brought them into our system called Swarm. And so we take these real people, we connect them together with AI algorithms, form an amplified intelligence. Again, that's artificial swarm intelligence or swarm AI, and we ask them to make predictions. And so this is what a prediction looked like. Who will win the Kentucky Derby? And so here the people are pushing and pulling, and the AI algorithms are watching all of their behaviors, and the system is converging on an answer. And again, what the AI sees is a cloud of information. And then we did the same thing for who will come in second, who will come in third, who will come in fourth, and we gave that data, those predictions, to the reporter who wrote a story, and that put a lot of pressure on us. And then she actually went to the Kentucky Derby and placed a bet on the superfecta and tweeted it out, which put even more pressure on us. And the reason it's a fun story is that we were perfect. So anyone who had placed a $20 bet on the four horses that she tweeted out would have won $11,000. I did that. I won $11,000. The reporter won money. One of her readers emailed her, told her he won $50,000 on that bet. And so this is a really good example of harnessing the human database. But more important than that is if you go back and you look at those 20 people and you say, well, how would they have done on their own? Not a single one of them would have gotten all four horses right on their own. And if they'd taken a vote, took the most popular answers, they would have gotten two horses right out of four. But when they worked together as a system, a deliberative system, they were perfect. And that is swarm intelligence. And so, of course, predicting the Kentucky Derby is not that's not proof. We partner with universities and done a whole bunch of academic studies. And so I'll give you a couple examples. We partnered with Oxford University, and we conducted a study of 40 sports fans and had them predict 50 soccer games in the English Premier League consecutive, and to see how they would do. And we looked at the individuals on their own were 55% accurate. If they took a vote, which is often called wisdom of crowds, they were 58% accurate. So a traditional vote works, it makes groups smarter. But when they work together as a swarm, they were 72% accurate. And all these studies are on our website, by the way, at unanimous.ai, if anyone wants to see the actual studies. We just studied with MIT, where we looked at financial forecasting. Financial traders, we asked them to predict the direction of motion of the price of gold, the price of oil, and the S&P 500 over 20 consecutive weeks. And when they worked together as a swarm, we amplified their intelligence by 26% more accurate. We did a study with Stanford Medical School, funded by National Science Foundation, where we had groups of doctors diagnose X-rays, and so an X-ray would pop up on their screen, and they would ask, "What's the probability that this patient has pneumonia?" And they would either do it on their own, take a vote, or work as a swarm. And these were small groups, just 4 or 5 doctors, and we reduced their diagnostic errors by 33% compared to taking a vote. And so what we found here is that swarm AI works. Groups can reach optimized decisions quickly and decisively as a real-time deliberative system, and the people are interacting as data processors, not data points for aggregation. But it only works with simple problems, numerical forecasts and multiple choice selections. And it's also not how humans deliberate most effectively. So this brings me to conversational deliberation. It turns out that conversational deliberation is the most important method for collaboration among teams, for evaluating problems, generating ideas, surfacing insights, finding solutions that can harness the knowledge and wisdom and insights of a group. There's a problem, though. Conversation is only viable for small groups. It turns out research shows that a group of about 4 to 7 people is a really good size for deliberation, but it's you get a good amount of airtime per person, and you get a small amount of wait time per person. But as you go larger, airtime drops, wait time increases, and by 12 people, it's really just a series of speeches, and above 20 people, it's chaos. And so this brings us to this problem. Well, what if you have a large group? 40 people, 400 people, 4,000 people. How do you hold a thoughtful and productive conversation? You could try to use Zoom. 40 people in Zoom, never going to work. It's chaos. There's really no method for real-time thoughtful deliberation with back and forth on any platform that's out there. And why is this a problem? Because the average Fortune 1000 company has over 30,000 employees, and yet only a handful are able to deliberate conversationally at a time. That's a problem in general, but it's also a problem for harnessing large groups for collective superintelligence. But we solved this, and we solved it with a little help from Mother Nature. And this brings me back to fish schools. So fish school is a large organization. There's thousands of members. Nobody's in charge. And yet they make life or death decisions to navigate their entire lives in the ocean together so well that biologists refer to them as a super organism. How do they do this? Well, first thing to know is that fish schools communicate using a special organ on the side of their body called the lateral line, and it detects pressure and vibration changes in the water around them, and it allows them to assess the intentions of the neighboring fish in their local vicinity. And this means that it allows these small local groups of fish to deliberate. They can basically have this local tug of war, pushing and pulling to decide which direction that local part of the school should go. But the really cool thing is that these local subgroups overlap. They all overlap. Everyone's neighbors are different, and so information propagates globally through the full school, and this yields smart, rapid decisions in real time. So let's look at an example. How does a fish school make smart decisions? Well, let's give this school a problem to solve, and here we have a situation where all the individuals have limited information. Nobody has all the information. In fact, no individual has enough information to make an optimal decision. Small pockets of fish can see 3 different problems. Most fish in the middle don't see any of it. And so what we see here is that really the information is coming in from small areas. We can see a group of fish in the upper left that can see a predator. They're going to have their little negotiation amongst themselves and want to move down and to the right. A group of fish down at the lower left sees a predator. They want to move up and to the right. And then this group of fish up in the right sees a predator and wants to move down and to the left. Okay, those things happen, but that's not a collective intelligence. That's not a decision. But because all these groups of fish overlap, the information propagates through the school, and you get this rapid, effective decision to address these complexities of life. Well, can we do this in large human groups? Can we allow large human groups to hold conversations this way? So here's 250 person group, let's say, and real-time conversational deliberation is currently impossible in a group this size. Well, Mother Nature would say, let's divide the population into small groups that are sized for optimal conversational deliberation. Okay, 3 to 5 people, let's say groups of 5. Let's turn it into 50 groups of 5, and we can do that. We've done that. We've had groups of people come into our platform, 250 people, they get broken up into 50 groups of 5 to deliberate a problem. That works, but it's not a collective intelligence, it's not a single conversation, it's not a superintelligence, it's just 50 conversations. Well, Mother Nature would say we should make these conversations overlap. We can do that too, right? So information can propagate. This fails. This fails because people are not fish. We didn't evolve like fish. In fact, we evolved the opposite. So there's something called the cocktail party problem, which is that if I go to a cocktail party and I'm talking to a small group of people, and then I hear another conversation right next to me of another group of people, and I shift my attention, I lose my focus on the conversation I'm in. In fact, I just cannot be in 2 conversations at once. It's impossible. And in fact, we evolved the opposite way of fish. We are really good at tuning out all the other conversations. We are terrible at having any kind of overlap between the 2 conversations. So this has been an unsolved problem. We've never been able to have large-scale conversations before, and yet we solved this. We solved this with an artificial agent. We call this a conversational surrogate agent. And this conversational surrogate agent gets put into all the little groups, the different agent in all the groups. And the job of this agent is to observe the insights that are happening in its group. What are the things that people are saying that are important, the ideas and reasons, extract those insights, then pass those insights on to the agents in other groups in a smart way. And those other agents, when they get those insights, will express them conversationally as part of the conversation. So if I'm in one of these groups, I'm in a conversation with 5 or 6 humans, and there's an artificial agent, and it's just watching us, and then it will pipe up, and it will offer an insight. It didn't make that insight up. It didn't grab it off the internet. It was an insight that came from another group. And so it will weave all of these conversations together into a single unified conversation that we call Conversational Swarm Intelligence, and it enables real-time deliberation among groups of potentially any size, and it amplifies their collective intelligence. And so we've built systems that do this, and this is what it looks like. This is a group with insights passing around, and we can have 40 people, 400 people, 4,000 people, but potentially even 4 million people. And what can we do? Well, we've had hundreds of people in groups like this where they can brainstorm problems, brainstorming together, building on the ideas of others from all around this network of 400 people. They could debate complex issues, arguing with each other across 400 people in real time, share knowledge and insights. People bringing different perspectives across 400 people. They can prioritize objectives. So if you have a group of people, they need to come up, what are our top objectives as a division or as an organization? They can prioritize and produce priorities that are more agreeable than other methods among the group. They can estimate requirements, how much is something going to cost, how long is it going to take, and be more accurate than other methods. They can forecast outcomes of they can ultimately just reach decisions together as a group. And so they can converge and optimize solutions as an amplified intelligence. We've built a variety of systems that do this. This is this architecture for text deliberations where information passes between groups. And text is really good. People like to communicate by text in this way. And I'll show you that. And they can also be anonymous when it's text. We've also worked on video deliberations this way, where you take a large video and you can break it up into groups. And this is not commercially available yet. But what we can do is we can put an artificial avatar into each of these groups that's driven by an AI agent, and it's going to express conversationally in this conversation the concept, the ideas from other groups, and weave a large video conference together. So we've deployed a real-time system called Thinkscape that large companies are already using to have these large-scale conversations by text. And I want to talk. So does conversational swarm intelligence make groups smarter? We partner with universities to do a whole series of interesting experiments. This first study we did with Carnegie Mellon is an estimation study where we asked large groups, 250 people, to estimate the number of gumballs in a jar from a photograph. And this is a classic collective intelligence experiment. People do experiments like this all the time because groups are better when you at doing estimations. And so what we did that was different here was this, which was we looked at 4 cases. We looked at what's the average individual, what's their error in estimating the number of gumballs in the jar from a photograph. We asked ChatGPT-4, and this is a year ago, so this was not the latest system, just a pure AI. Then we looked at the wisdom of crowd, where we took all the different estimates and averaged it and see what kind of amplification we would get. And then we looked at conversational swarm intelligence, when the group could deliberate. And people got the same amount of time to do this in all cases. So the average individual had a 55% error, which is high, but this is hard. ChatGPT-4 gave them the photograph, 42% error, which really shocked me, better than the average person. And this was, again, over a year ago. So we do have to worry about superintelligence, right? Wisdom of crowd, when the group worked together, took the crown back, 25% error. Great. Cut the error down in half. And then conversational swarm intelligence, when the group could actually deliberate as a system, as data processors, not as data. 12% error, cut the error in half again. And so this works, and it makes a significant difference. And again, this is on our website. Then we did another study, also with Carnegie Mellon, where we gave groups of 35 people IQ tests. And it's a graphical IQ test called the Raven Matrix test, standard IQ test. And we looked at 3 cases. We looked at groups taking the IQ test alone. We looked at wisdom of crowd, where we took the most popular answer for each question. And then we had these conversational swarms, where again, where the group were broken up into little groups of 5 and information is propagating all around. And what we found was that the average individual had an IQ of 100, which is how IQ tests are designed. Then we looked at the wisdom of crowd, where the group, we took the most popular answer, and that made a difference, a big difference. It amplified the group's intelligence to 115 IQ, the 81st percentile. So when the groups work together then like this, they do get smarter. Wisdom of crowd works. But then when we had the groups deliberate as conversational swarms, the IQ jumped to 128, 97th percentile. And even more amazing is that in these groups of 35 people, it consistently outperformed every member of the group. The collective intelligence outperformed every member of the group as a conversational swarm. And this is really the first evidence of a collective superintelligence where the group is smarter than every member. This is what the results look like. And again, these papers are on our website. Okay, now we asked, what if the human participants could also get information from AI agents? And so we created a new type of agent called an infobot that goes into each of these little rooms, and it can answer questions about a specific topic. It's trained on just a specific topic. It can just answer factual information. So it's different from the agents that are passing information around. It's an additional agent. And we tested this in a study with Carnegie Mellon for fantasy baseball. What we had groups of 30 people hold real-time conversations in Thinkscape to draft a fantasy baseball team for the DraftKings daily contest. And if you know anything about fantasy baseball or fantasy sports, you have a budget. You have to select among a set of players, make trade-offs about how much you're going to spend on this player and that player. So just imagine having 30 people get together and do that together in a big room. It would take forever. We're going to do that inside of Thinkscape as a conversational swarm and give them the exact same amount of time as if they were doing it alone. And we added a baseball infobot. It's trained just on baseball information. It could answer questions about any player, any statistic, any team. You know, which player has a higher batting average, so and so or so and so, and the infobot will answer to that group. And again, the infobot, this MLB infobot, goes into all of the rooms. And so if you ask a question inside of your room to the infobot, everyone in your little conversation sees it, but other questions are being asked to the infobot in other rooms. So it's all happening in parallel. And now we looked at 3 different cases. We looked at the average individual, the wisdom of crowd, and conversational swarms. The average individual scored 47 points on this DraftKings contest. And we did this over 10 weeks. This is 10 weeks of studies. And the key thing to know is that the individuals who participated, they were also able to search for information. They could search the internet, they could use ChatGPT, they could do whatever they want to get information. They had their own methods. We also looked at the wisdom of crowd. What if we took the most popular choices across these groups? And it turns out the wisdom of crowd did worse, 44 points, the 39th percentile. Well, why is that? That's because this is not a simple problem that you can just aggregate data. Why? Because different people have different strategies. They're just making decisions globally across, like, well, I want to spend more money on hitters and save money for a really good pitcher. There's this global strategy that doesn't exist in individual data. How do you converge on a strategy? People have to deliberate, negotiate, talk about these issues. And so wisdom of crowd failed. Conversational swarm, the group scored 62 points when deliberating as a conversational swarm, up to the 73rd percentile. So significant amplification of intelligence, and this works. Okay, now let me talk about Thinkscape, which is the software platform that we used, and it is commercially available. So groups of up to 400 people can log in from anywhere in the world. And when they log in, they enter a world that looks like this for real-time text conversations. There's an area where you can see who all the participants are. There's over 100 people in here right now. They can have usernames, or they could be anonymous. There's an area where the group can chat, just standard text chat, all the standard features. There's also the ability to do voice to text, so they can just speak into it and click send, so they don't have to be a good typist. There's a media area where you could share data, spreadsheets, videos, anything that the group is going to be talking about. And then there's the conversation deliberator, a visualizer, which shows in real time what's actually happening. It shows that this group of 112 people are split up into 23 different groups that are all interconnected, and it shows as information gets passed between groups. And then there's a question area where a moderator can ask a question, And in this case, this is from a real experiment with a real market research firm who wanted to use Thinkscape to generate insights from a large group of consumers. And so the question they asked here is, which of these snack brands is most associated with novelty and why? Typical focus group type of question, but instead of a focus group involving 8 to 10 people, we now have 112 people who are going to engage in a large scale focus group, deliberating, generating qualitative insights at quantitative scale, statistically significant qualitative insights. And it's never been possible before. And this is what it looks like. So this is sped up a little bit, but the group starts deliberating, 100 people. This is the moderator view. And so this is all of the conversation. Nobody would watch it in this view, but you can see what's happening as the groups are deliberating. But the cool thing here is that you can click on any one of these rooms, we call them think tanks, jump in, and you can see, oh, inside that think tank, there is a coherent conversation that's happening. The people are deliberating, information is appearing. If there's an infobot, people are talking to the infobots, and then information is being passed between rooms, weaving it all together. And then there's also a place where you can click to see the insights in real time. You get the bird's eye view, which is really how most people watch the session. If you're asking questions or moderating, you can see how the sentiments rise and fall for the different options. There's a place where you can see where key verbatims are going by, so you see key influential statements going by. You can see statistical significance. There's lots of other data here I won't go into, but the key thing here is that you can watch this conversation, and this is just a 5-minute conversation. They're just deliberating in 5 minutes, and they're getting more insights that they would have gotten if they'd spent an entire month running focus groups. And then as soon as this question is done, because we're analyzing all of the information in real time, you get a summary of exactly what this group came up with. And so here's, and we have an artificial agent that delivers it. So here's the summary.
I am Una, a collective intelligence created in Thinkscape by connecting 112 consumers in AI-powered deliberation. Our collective perspective is that Cheetos is the brand most associated with novelty. That's because it offers a variety of bold flavors, has unique advertising, and offers experimental options that represent adventure. We also find Cheetos to be a reliable pick-me-up and a nostalgic brand. For more details, please see the full written report generated by Thinkscape.
Okay, so Una just mentioned a full written report. And that's the other thing, is that the system, because it does all this analysis, it breaks the conversation up in real time, it automatically generates within an hour a full written report about what the group actually talked about and all the insights that were generated. So here's a report that was generated for a different question. This one was, should the US build new nuclear power plants? This was done for a project we're doing with the Department of Energy. It was 111 participants. They were debating issues, raising issues, brainstorming together reasons, and the system automatically puts out this report where it lists all the insights that came up. It gives you a sentiment, it gives you a conviction, it gives you statistical analysis, it shows how people were swayed or not swayed, it gives word clouds, and then it goes into detail for every argument that was made and the positives and negatives of how those arguments were made, and then it delivers this report. And this entire report was generated for an 8-minute deliberation. And so a group could come in and have a bunch of different questions asked and generate these detailed reports. And again, if you were trying to conduct interviews or focus groups, it would take months. And this entire effort was done in 1 hour. And so this brings me back to Collective Superintelligence. And again, as I mentioned before, the key thing here is to add the human database into the system. But now we have a method for doing that. Conversational Swarm Intelligence, where the groups are deliberating. And the cool things here are that each individual person is a thoughtful, interactive data processor, not a data point. Every individual can share their knowledge and expertise and insights and intuition. And if their ideas have merit and gain support in their room, they get passed on to other rooms. And you can see how these insights spread that gain support because they are convincing. And then the participants can brainstorm and debate together, raising points and counterpoints. And we can bring infobots into the system so groups can ask questions in diverse ways and bring information in. And then, of course, we're also leveraging the human values, human morals, human ethics, and sensibilities of the population. In terms of current use cases, we have diverse organizations using this technology now, from large corporations to the Department of Energy. Some of the uses that we're seeing, certainly market research and consumer insights, because you can generate qualitative insights at statistical scale, really revolutionizes how we capture insights from large groups of consumers. Product development and product planning, large groups of employees in engineering or production groups can deliberate, can make decisions, can predict how long something's going to take, how much it's going to cost, brainstorm together. Strategic planning and prioritization across groups and organizations, where you could prioritize sets of objectives. Forecasting, obviously sales forecasting, financial forecasting, market forecasting. You could do it scale, deliberatively, conversationally, and employee engagement. You can bring in whole divisions, whole companies together to provide input and to deliberate. And we see it actually fosters buy-in. We've done studies where we've looked at, like, what if you send out a survey to a large group of employees to get their input, get their knowledge. That does not foster positive feelings, because when the results come out, it usually doesn't match what they said. But if they participate in the deliberation and they observe the give and take and how it converges, they actually have significantly higher support for the results. And then bring together groups of subject matter experts. We have projects with the Department of Energy, U.S. Air Force to do that. And then looking forward, future use cases, large-scale science and engineering efforts, things like the Apollo project involve thousands and thousands of engineers and scientists. You could potentially bring those together to do deliberations. And then large-scale civic engagement. You want to capture, know what your constituents are thinking. You could do a survey, or you could bring them together to deliberate and really give input on sophisticated issues, deep issues. Before I close, I want to give one fun example, market research example. We were asked by a market researcher to predict. There was the Paul versus Tyson fight that just happened last week, and we were asked, will this be one of the most watched sporting events in history? And we said, we could find that out in 10 minutes or less. And so we used Thinkscape. We brought in 107 sports fans, randomly selected into Thinkscape, and we had them to conversationally deliberate for 8 minutes on the pros and cons of why they thought this would be a high-profile event or not. And this is what we got.
I am Una, a collective intelligence created in Thinkscape by connecting 107 randomly selected members of the public in real-time AI-powered deliberation. Together, we discussed whether the Paul versus Tyson fight will be one of the most watched boxing matches in history. Ultimately, our collective perspective strongly supports that this boxing match will achieve record viewership due to Mike Tyson's overwhelming popularity, interest in Jake Paul as a controversial figure, the ease of access on Netflix, and the unique generational span of viewers, with older generations following Tyson and younger generations following Paul. We also identified an overwhelming desire among the public to see Jake Paul lose this fight, ideally in a knockout. We then made a probabilistic forecast using Thinkscape's unique graphical swarm feature and converged on a 70% probability that live viewership will exceed 25 million. This would make the fight the most watched streamed sporting event in history.
So is this a good forecast? It turns out that it was. The fight just happened on Friday of last week. There's different estimates from 60 million to over 100 million viewers, but it definitely was the most watched sporting event by a factor of 3, a factor of 4. And that's the power of capturing information in this deliberative way. You can get really accurate insights really quickly and get detailed information about why the group thinks the way it thinks. So that's the state of the art in collective superintelligence. I'm Louis Rosenberg, CEO and Chief Scientist of Unanimous AI. If you have any questions or information, you can find us at Unanimous Thinkscape.ai. Thanks.